Hello and welcome to this Code Rage session. This is an introduction to FireDAC with InterBase. Now this is a beginner level session, however even if you've been using components for a while, there's going to be some tips and tricks around the FireDAC components that are reasonably new that may be worth hanging around for just to find out. So my name is Stephen Ball and I'm a chartered IT professional. I've been with Embarcadero for a few years now, and before that was commercially producing applications in the real world with Delphi and InterBase. And I'm a technical sales consultant here on the RAD Studio products, and I'm also now the Associate Product Manager for InterBase. If you'd like to get a hold of me, then stephen.ball@embarcadero.com is my email, or you can just follow on the blogs or interact with me on Twitter, which is where I seem to be spending a fair bit of time at the moment, which is @DelphiAbul. So let's start off with what is FireDAC? Well, if you're learning anything to do with the RAD Studio products, I'd highly recommend checking out DocWiki. DocWiki is our online help pages, and docwiki.embarcadero.com. You'll be able to find a link to a number of our products there, including Delphi, C++ Builder, HTML5 Builder, and so on. Now, through the help pages there, you'll be able to find the FireDAC reference, and there's a very good online set of resources there to work through, which shows connectivity to a whole range of different databases through FireDAC. Now, FireDAC provides a very powerful common architecture for connecting out to different databases. Now, we all know databases tend to have a lot in common, but also a lot that's not in common. And FireDAC really cuts through that to make it very easy for us to connect at very high speed, direct from Delphi to InterBase, SQLite, MySQL, SQL Server, Oracle, PostgreSQL, IBM DB2, SQL Anywhere, Access, Firebird, Infomix, and a whole load more as well. There's an ODBC driver in there that allows you to connect up to pretty much anything using ODBC. The way it does this is it helps us either from FireMonkey or from the VCL, or you could, well, pretty much actually any application built with Delphi. It could be web services, it could be a console application, but any Delphi or C++ application then comes through the FireDAC stack to then connect down to the database. So there's a set of non-visual components which we use, and there's also a set of visible components and form GUI components that FireDAC has out the box for you to use. They connect in through the local storage and the data adapters to actually connect via the physical drivers down to the database level. And by having this abstraction in between, it means when you've got different databases that may have different field types that are pretty much the same, so especially around kind of numbers and strings, where the field types are slightly different between places, FireDAC actually manages that for you, and you can map to different data types to come into the physical application you're writing. So it makes it very easy to map and switch databases. There's also a whole load of scripting things that you can do within the SQL, in your SQL syntaxes, to enable it to run differently on different database engines, and FireDAC will parse that and sort that out for you as it runs through. Or if you're like me, just prefer using straightforward SQL syntax, then you can go ahead and do that, and it will map. Obviously, you just need to be aware of the language features that you use for different databases. Now, I know we talk about FireDAC being fast, but I want to share with you a story from being out on the road recently. I was talking to some developers over dinner before an event in Sweden, and they were saying how they'd switched from ADO, talking to their MS SQL database, to FireDAC, and had seen an immediate speed improvement beyond what their previous connections were doing. So much so that they rolled it out as an update purely as the only feature that they put into it. So it really is very, very fast, and some of the ways that we can talk directly to the databases, depending on the actual database capabilities. For example, through Oracle, we can actually update records back by the Oracle database record ID, which is even faster than updating it by a field ID. We have parameterized queries for being able to post back multiple updates at the same time, again increasing the speed that it takes to update records and post records in, improving the performance of your applications. And it does all this using a set of components. So here's our example. We're going to be looking at InterBase today. However, whichever database you use, it's very much the same way of connecting through. Let's start off with the application layer here. So we have a TFD connection, which is our FireDAC connection. This is our connection to our database. Now, against this connection, and you can have one or multiple connections in your application pointing to the same or different databases, we then have a number of different components, and I've just got an example of 3 of them here, that allow us to communicate with the database. So we could have a query, we could have direct access to a table, or we could be connecting to stored procedures here as an example. Now, with your database, there's 2 additional components that you need, and these are singleton components. So we have an IB driver link here. So this is a physical IB driver link. We have physical links for all the different drivers that we support. And you just need to add one of those to your application to allow it to know how to talk to that database. Now, this is great because unlike DB Express, where you need to actually reference the driver that you want to use and then supply that driver with the application, here, by using this physical driver link, it's actually built into the application, so you're not dependent on external libraries to be shipped with the product. However, that doesn't stop you from needing the drivers installed on the machine, but you don't need a physical database layer driver to talk to the local database technology. The final component that we have here is the GUI wait cursor, and we need one of these either set for VCL, FireMonkey or console, and this just helps FireDAC understand how it's going to interact with the screen when it's running tasks that are maybe taking some time. If you're updating 10,000 records, for example, and that might take a second or 2, then this controls how the cursor is managed, so you don't have to worry about anything. So that's what we need to worry about. Now, we could easily swap the physical driver out and have a different database layer that we talk to and maintain the rest of this without having to make any additional changes in our application, which means using FireDAC, it becomes very easy for us to work with multiple database technologies. Now, there's 4 main sets of components that FireDAC ship with. There's the FireDAC section under the component palette, the tool palette, and this contains what you use to talk to the database in terms of this level here. So we have a connection, we have a manager, we have transactions that you can use if the database you're talking to supports transactions. We have our memory tables, our queries, our stored procedures, tables, update SQL components. So you can specify specific update SQL that you want to use. We have some script, metadata, event alerts if your database supports that type of thing, and a local SQL manager. We also have our FireDAC links. So those are these ones over here, and you can see here is the ODBC one for flat file, for remote clients, for Firebird, for MySQL, Microsoft Access, Oracle, there's the InterBase one, there's a whole set of different drivers in there. Now, we then have the FireDAC services. Now, FireDAC services allow you to do a number of specific things against databases. Now, these tend to be rather database specific. So, for example, here we can see the FireDAC IB backup, which is selected. The services ones are about the only thing that really are specific to the database, because they are doing stuff that is very specific for the database. And they don't quite have the same mappings as you would with queries and SQL syntaxes. But typically for the databases that we support, then you have backup and restore. There may be validation, security checks, or user security referencing. So there's a whole set of things that you can use. InterBase has quite a full feature set here around being able to produce out dumps and configs and so on. Now finally, there's the user interface components that allow you to have a login dialog, to have asynchronous execute dialogues running. So if it's taking a while for things to run, then you can pop up a dialog to manage that. And also the cursor management, which we've noted already. And that's actually required. You need to have a wait cursor added to your application along with your connection and your link. Now, there's a few things that I want to raise that we're going to talk about and focus as we go through here today. But first of all, FireDAC uses T-field, T-datasets, and is built from those, just as the T-client dataset, just as the BDE was, just as the DB Express has been as well. So T-field is not something you directly create yourself, but is used by a number of different field types, and T-field brings in a whole set of functionality that specific fields will go ahead and implement. T-dataset, again, defines a dataset and behaviours of a dataset, being able to navigate them, go to the beginning, to the last record, find out when you're at the end of the file, so on, being able to get a count of the number of records and so on. So datasets provide a lot of common functionality. If you're writing code that you want to use a lot with multiple different types of controls, and you don't want to limit yourself to if it's a table, or if it's a query, or even if you're using it with other component sets, then being able to pass the object as a T dataset is something that is very useful to be able to understand. Now, we're going to be looking and using a data module on occasions through these demos. A data module allows you to put components onto a container that's non-visual, that you can then share between different applications and work with. And data modules are a great way to be able to put your data components onto an area that you can then see and work with. Now finally, one of my favourite tips around FireDAC is a very, very useful property on the FireDAC connection. Now this is connected stored usage. Now this basically allows you to store if the database is going to be connected at design time and or runtime. So quite often when you deploy an application, you don't want it to be connected at the point that you go and run it. You want the application to load up some parameters for where the database is and then go and connect. This is a common thing that developers kind of hit against when they're doing database development, is they need to remember to disconnect from their local database connection if they're doing any work before they then go and deploy their application. Otherwise, they need to make sure the database is on the same location as their current machine. FireDAC takes care of this for you just by setting the runtime connected stated usage to false. And when you go and run, whatever it's been at the point you compile, it's always going to be connected false, and then allows you to load up and connect to it manually, which is pretty cool. Okay, so I want to get in and show you where some of those properties are, and also show us our first application working with FireDAC. So first of all here, I've got my IB driver link I've got my FireDAC connection. You can see it's connected false at the moment. Here's the connected stored usage. So I could say at runtime, don't store the connection state. And then I can have this connected at design time, which is fine without any problems. Here's my query. So my query, when I add it down to the form, automatically connects up to the server connection. So let's just double click on the query here. We can see this is selecting staff from employee. Now if I execute that, I can see that's bringing back some data, which is great. What I should show you here is actually the database connection. So here on a database connection, we can select IB as our driver. We can come in here and go select our example database, and we'll build an application from scratch in a moment. We can put in our username and password. We can set the protocol that we want to be using for connectivity. We can set where our server is. We can set the SQL dialect. Now the dialect, typically you're going to be using SQL dialect 3 now. Dialect 1 and 2 are from a very long time ago. Dialect 3 is by far the way to go. Certainly for any new application, but if you are using older applications, then you can change the dialect here. We can also set the page sizes that we're working with to help improve performance. And if we've got an encrypted database, then we can provide in here our security passwords that we've been using. There's also a whole load of options in here for data mapping rules. And if you set these on the FireDAC component here, then they'll iterate through all the components that are connected to it. So you only need to set it in one place, and it will take care of managing that throughout your application. Here we can see a summary of the information for our connection. And if we wanted to try and run some SQL script from here, so maybe let's just try select staff from employee. We can go run that and we can see what it turns back, how long it's taken to do that, and if it's caused any errors. So this is quite useful for being able to just check elements of what we're doing if we want to. Okay, so we've got our connection, we've got our query. This is a VCL application, so we're going to use a data source here connected to our query, hook it up to a database grid, and we've got a few lines of code underneath here just to help us along the way. So the first one we're going to do is we're just going to enable our connection at runtime. We're going to open the query, and that's going to show the data into the grid. Now we can see there's two other lines of code here, so let's just go find where they are. The first one is on the button. So here we've got a button one click event, which is called apply, and this just applies updates. Now with the queries, you can either have it so it posts the updates directly to the database straight away, or you can wait and tell it that you want to post the changes when you're done. So here we use cached updates, which means we're not going to post any changes until we physically tell it to go apply the updates. This allows you to actually be able to cancel updates, cancel editing prior to having them applied into the database. So this is very useful. The final thing that we had was an event on the grid. So if we come down here, we can see on title click. Now this allows us to have an event that when the grid title is clicked, we're going to do something. So we're going to take the current column that's been clicked, take the field name from it, and set this as the index field name on the query. So against the queries, we have the chance to order the data outside the SQL statement using the index field name. Now if you want to connect indexes at design time, or you can create these at runtime, but you can come in here and the index field names, if you pop it up, you can select the field name that you want. or you can, just above here, on the indexes, you can come in here and you can create an index and set in descending fields, so which ones you want it sorted in reverse order by, and so on. So there's some flexibility, or enhanced flexibility, about creating indexes, specific indexes that have specific characteristics rather than just the straightforward field name. But we're gonna go with just this nice easy one here, the index field name, setting it to the column field name to order the data by that. And if we just go ahead and run this, we can see here, if we click on the first name, it orders them by first name. Click by last name. We can come in here, we could change some data. Now this data hasn't been applied to the database yet. If we just go and close this, we'll be able to see Pierre and rerun. Now where is Pierre? Pierre Osborne, there he is. That hasn't changed to Smith, which is what we just changed it to. If we do go ahead and apply updates, we can now see that's reordered, put him in the right place. And if we close and let's just try and run again, we'll be able to see that Pierre is down here. So I'm just going to change him back to Osborne, apply, and that's all got job done. So that is all we need to do to be able to update data in a data set, send it back to the database. You notice there's no SQL statements I've written here for updating the data or doing anything with it. It literally is fetch the data, work with the data, and apply the updates. So there's a number of different ways that you can work with the data. Let's go ahead here and let's just go ahead and run this again. We can see that we've got our salary field. So if we wanted to increase everybody's salary by 10, then let's go ahead and put a button on here. And we could do the following. We could say FireDAC query, which is the name of the query we've got to. We could send it to the first record, and then we could say while not FireDAC query to.end of file, so EOF, do begin. Now the first thing that we need to make sure that we do is not get stuck in a loop. So we need to tell it here to move to the next row at some point. And that will keep going through till it gets to the end of the file. So in here now we can just say FireDAC query dot edit, and then we can say, we can choose either field by name and pass in the field name, or if we come into, if we right click and go to the field editor, we can right click and we can add the fields in, and here are all the fields. So as we've added the fields into the data set, we can now choose the actual item, the different field. So we want to go to get the salary one, and we can set the value, which is a currency here, or we can do as currency equals, and then we can just do this plus 10. And maybe what we could do here is we could just check first of all to see if there is a value in the field. So we could say if this is null, so if not is null, so we want to do it if there's a value in there, then we can go update that record. And then we can just, here at the end, just post that change into the data set. Move on to the next record and iterate through. So let's go ahead and run this. Let's go find all the salary fields. If we click our button, we can see that's gone ahead and updated each of these to have an additional 10. So because I didn't post the changes or apply the changes to the dataset, they only happened and maintained in memory. If I wanted to post those changes, I'd need to choose the Apply Update button to post those changes back through to the database. Now that's the case again, because on here I've got cached updates to true. Okay, so I'm going to go and close this because I want to explore another FireDAC application. Now this one is actually a mobile application using FireDAC. Again, you can see we've got the IB physical driver link. And if I just move these components up, you can see here we've got two database connections. Here we're using different users to connect back to the same database. But I want to explore how we actually set these components up so we can actually use them within the application. So the key thing here really that's different is setting the database path. And there's some very useful stuff that we can do across multiple platforms, and this just happens to have an example of it in here. So in the form create, we can see here that we're using an if-def here because on my Windows machine I've actually got the database set to a specific path which I've got set into the components. So in here, if we go and have a look, we can see this is pointing at C data, my employee column encrypted database. Now that's great when I'm at design time and I'm working. You can see here we're using the connected stored usage to say that we don't want it to store that connection at the point that we run the application. So we need to set the connection and then set it connected. So that's what we do in the form create here. So basically, if I'm not running on Windows, then I'm deploying this out because this is meant to be run on a mobile application. The only time it would be run on Windows is when I'm debugging it. So if it is, then great. So if it's not running on Windows, then that's what the N in the not def find. We come use the T path. We get the documents path, which we return back for Windows or for return back for any platform, basically the documents folder. Here we pass in the path delimiter. So depending on the platform, the path delimiter will either be a backslash or a forward slash. We're then giving it an InterBase folder, a path delimiter, and then the name of the file. And then I'm just setting the second database parameter to be the same as the first. Whichever platform, and because this one's got encryption in it, we've just got to set the password. So this is very, very useful, this tpath get documents path, and then passing it InterBase in. Now if we come in here and have a look at the project deployment, this is the one place that we need to actually come and do something to ensure that InterBase will be used. So under the add feature files, we need to just make sure that we've got InterBase to go selected for the platform that we want to deploy it with, because we're embedding InterBase in. If we're just deploying an application that is connecting back to a server, then we can just use the InterBase client. But here we're actually got InterBase embedded into the application, so we need to select InterBase to go. And you can see here what files this will then go and distribute for the different platforms. Now the key thing is obviously just to put your registration file in the correct directory. So to find the InterBase path, we just need to go to C, go to users, public documents, InterBase, redistribution, InterBase exe3, and you can see here I've got my license file within my directory. Now that's all you need to do. I just rename the file that I get emailed through to reg_ib to go, and then it will then just automatically pick up. So with the file, if we go and have a look for those, we can see here that all the InterBase files, and in here I include my database, so I just select add a file, go select the database file, and then on here for Android we just put this to assets internal InterBase, and that's where the tpath.getDocument folder will go to. For iOS, for the iOS device, we can see here that we put this to startup documents InterBase. and that's where we need to put our database file. And the InterBase assets will go there, and that's everything that we need to run InterBase is included into there. Okay, let's just quickly check here. I've got this targeted for iOS simulator. That'll do just for the purpose of this demo. Equally, I could target it out at an iOS device or to an Android device. But let's just go and try and run this now. So that's now going to go and compile it, run it across to iOS. And we now see no data, turn our switches on, and we can see data. So that's great, very, very easy for us to use the tpath.getDocuments path to set the database parameter. So what we're doing here is the parameters that we can see in this connection screen, each of these have a name. So this one here is called database. So under here, we're able to say to our connection, to the parameters, to the value for database to set it to a specific string, as we're doing here for the value for username and for password. So if we have a look in here, we can see here username, password. So you can literally just come in here, any of these down the side here, you can go ahead and set in code just by using the parameter and then setting the value. Okay, so let's have a look at some other stuff that we can do around parameters. Parameters are very, very useful, and we actually use those in queries. So I'm just going to go ahead and close all of these. We're going to build a very pointless application, but just to show you how to use parameters within queries. So let's go ahead here and put down a FireDAC connection. Let's have an InterBase physical driver. Let's have a FireDAC query, and let's have a GUI wait cursor, which we're going to use set for FireMonkey. Okay. So with the database here, let's connect it to an InterBase driver. Now the database that we're going to connect to here, we'll go find the sample that come with RAD Studio. So under Documents, under RAD Studio, you'll find the version number, so currently this is 12, and in here is the samples folder. Now if you've got a Tortoise SVN client, you can right click and update these, but in here there's a samples data folder, and we're going to use the employee.gdb. Now the username, password, sysdba, and master key is the default password, which if you're deploying applications out, you'd probably create your own username password for the databases. Specifically, from a security point, that's a good thing to do. So let's just say OK. Now we can just check our connection here. If we don't want to have that dialog box, the login prompt, we can disable that. Now in terms of a query, let's just go ahead and open IB console here a second and log into our local server, connect to our database, and here's the data. So this is great. We can see we've got a database with some tables, some stuff in here. I'm just going to create a new table in here called my table, and I'm going to add some fields. So let's have my description. Now I could select a domain. I'm just going to use a specific field type here. So let's just give this a varchar with a length of 10. That'll do for just our example. And we can leave that as it is. We could set a default value or whatever. So that'll do. We just got my table with my description. So let's go ahead and put a button down here. And we can either set the SQL up at design time, or we could do it at runtime. So we know it's called my table. We could actually, if we were using a table property, FireDAC table here, you could just link this up to the table property, the table name. I'm just going to use that here though for my query. So I'm going to say FireDAC query1.sql.text equals insert into my table, and then we know it's just a single field, but so we could do name, values, description. So well, let's do that. So my description, values, my description. Okay, so this semicolon here, we could put whatever we wanted here. That's just to give us a name of a parameter. Now, obviously, we don't know what the value is going to be until we run. So we could have here an edit, and we could say fd query1 dot param, and you can see you've got param counts. You can iterate them. You can do params dot iterate through them. I'm just going to param by name here. My description dot value. Or we know it's a string, so we could do as string. Just equals edit1 dot text. Now parameters are very useful, especially from a security point, because if we just built this up by saying, let's just comment this out of the way for a moment, by saying plus edit1.text plus that, somebody could write whatever they wanted into the edit1. They can actually do SQL overloading, which kind of terminates this statement and then runs some naughty script and so on. So by actually using parameters, whatever they try to put into here is going to be protected by the parameter. And then all you need to do is you can say here dot execute SQL, and what you can do is you can say if equals 1, then begin, then show message posted. If it's equal to 0, then it's going to have failed. So let's just go ahead and run this. So let's just go ahead here and then fd query1 dot execute SQL. So we're just going to put hello, column unknown, my description. Helps if I spell it right. My description. Let's try again. So hello. And let's type in now world. So if we now go and have a look at our database, we'll be able to see in our tables, in my table, and we can see the data, hello world. Okay. Okay, so in terms of stored procedures, here we can just set the FireDAC stored procedure down, and again with the stored procedure we just need to come in here and find the name of the stored procedure that we want to work with. So there's a number of them here, so I could say let's choose the mail label one, and in here we can now see the parameters that come from that stored procedure. So we can see here that this is an input and these ones are outputs. So we could say, let's use this same button click here. We'll remove this, and we can just say FireDAC stored procedure 1 dot params. Now we know it's the first param, so we could do params 0, which is okay, but I'd much rather call param by name, just because I think it's a lot safer in case somebody goes and reorders things. So let's go and have a look at the params again and just check what the name was. So this is cust_no. And we can say that's equal to edit1.text, and we can just do here int to strt int. And then finally we can say FireDAC stored procedure 1 dot execute, and then we're able to get back let's just do, let's do this. For I equals 0 to FireDAC stored procedure 1 dot param count, do begin. We just need to define I as being an integer, and let's pop a memo on the form here. So let's just do memo1 dot lines dot clear, and then do memo1 dot lines dot add, and we're going to choose fd storeproc1 dot params I dot as string. We need to param count -1. There we are. So let's go ahead and run this. Now let's just try number 2, number 3. I'm not sure of an ID here. Let's just go find an ID for a customer. So we've got 1001 upwards. So let's just go ahead and run this with a parameter. So 1001, there we are. We can see the data is brought back nicely formatted. 1002, 1003. So very nicely the stored procedure here. Here we are, the mail label 1. We can see this is running all the the business logic here to go and process and work out how to build this mail label and provide us back the data. So nicely from the stored procedure we can connect and execute and fetch that data back. Okay, so finally, before we sum up, I just want to show you the FireDAC service components and how you can use those. These are very, very useful components to have when you're working with a database, because they allow you or your support team to be able to do some, or even your customer to be able to do some very simple stuff with the database to help it work and keep working. So we're going to have a quick look at the backup, restore and the validation components and how simple they are to actually use in practice. So here I've opened up another project which is an admin tool. I've got some common connection properties that I'm going to be using across all of these connections, and down here I've got chance to be able to pull back server users, to backup, restore and to validate a database using a range of different options. So let me just show you the code that's underneath here, and one of the things that we're using here is a data module. Now, a data module is a container that allows us to have a whole load of components put down, and I'd probably suggest that for the lion's share of what you do, development-wise, the best place to actually put your database connection, your queries and everything are actually onto data modules that you then make available into your applications. So here I've got my physical IB driver, I've got my wait cursor, which is set to FireMonkey, which is this application's a FireMonkey application. You can choose the different ones from in here. I've then got my backup, restore, validate and IB security components from the tool palette, and with the memory table, and the memory table is going to be used by the security component to be able to load in its data. So let's have a look underneath the hood here. I can see that I've got a few procedures that have been created, and they will pass in specific values. Passing in a lot of Boolean values here for different things. And on my data module, I'm then updating the backup username, password, the host, the security password, what the database file is, what the backup files are. If we want to export the output onto the screen, then just kind of clearing the log and then adding these options here using a little inline procedure just to add all the backup options onto the backup component before we then call backup. And again, for the restore one, we're doing very much the same here. Just if we're using a specific option, then add it into the option set. And for the validate, again, just setting these options into the backup set, into the validate set. So very, very easy. I've just encapsulated this data here onto into a data module. Because one of the things that we are using here is each of these components has an on error, on progress event, so we're able to specifically log out to the log if it's assigned. So we're using this log method here just to check, and if the log is set up, then push it through. So within my code here, all I need to do is literally just go ahead and call the methods. So let's go run this and have a quick look. For example here, I can pick up the different database users I've got. I could come in here and select the database file that I want to use and where I want to back it up to. I can set the options and run the backup. I could do the same for validate, restore as well. So very, very simple to go ahead and use these options. If I was to back this up, in fact, let's just choose the non-encrypted one so I don't end up. So I should now be able to, let's just change this to test.ibk. So there we can see it's processed, it's pushed out the everything it's been doing, and including closing files, committing and finished. So there we are. That's all pretty good. We can go and see now. We'll have the data, the test.ibk file in the C data folder. There we are. Test.ibk has been created. So very, very simple to use those components for doing the admin features as well. Without having to know anything about the database, I can just go ahead and set the parameters, run them, and the job will be done. Now, FireDAC isn't your only option for connecting to InterBase. You can use DB Express, but really FireDAC is much faster and more suited platform for moving forward. The other option is to use the InterBase Express components, which are shipped with the product, and they offer a lot of the same functionality and are specifically targeted up only for InterBase Low. So if you are looking to use multiple different databases, then FireDAC really would be the way to go. Now, just a parting word about InterBase. We've seen it's very easy to work with here with FireDAC. InterBase can work on Windows, on Mac, on iOS and on Android, as well as Linux and Solaris. It's a highly scalable, powerful embedded database with lightweight, fully featured, full SQL92 compliant support. It's a multi-versional architecture, which means that you can move it up between different editions, and it also has a very simple install. In fact, on the remote devices here, we've seen how you can just embed it in. There's no installation required. The total cost of ownership of InterBase is exceptionally low because it doesn't require a DBA to be working with it, and a good part of that is because of the automatic crash recovery. It's also a self-tuning engine, and most importantly, when you're building business applications, it has full-featured encryption built into it, 256 encryption and a lighter weight 56-bit encryption. Now, when you're looking at the other sessions we're running around InterBase, you'll be able to see why having encryption, especially around business data on mobile devices, can save you literally millions of dollars in fines if data falls into the wrong hands. So very, very truly is a great option to have on whichever platform you're running. Now, there's a further set of video tutorials around InterBase available. If you go to embt.co/InterBase Labs, it is case sensitive, that URL. So capital I, capital B, capital L. There's some great videos there exploring InterBase further, and we'll be adding to those some FireDAC examples through the coming year. So now really it's time for some Q&A.
There's a question here about how much does it add to your mobile application in megabytes? I actually did test. It was just a couple. Was my experience. What was your experience?
To be honest, I've never checked particularly because it's what you're comparing it against, really.
Yeah. It was just a couple megabytes. I think 3 megabytes it added to my application. I just tested it here, and which really isn't that big a deal. I guess also it depends on if you've got debug mode turned on as well. That'll obviously increase the size of what it adds. So just make sure you've got release build as well if you're going to deploy it out at the final end. So it's kind of a good tip to keep that size down. Is a TDGUIX weight cursor required if the app is a Windows service, i.e. no GUI?
There's 3 states that you can set on the GUIX weight cursor. It's either VCL, FireMonkey, or console. Now, I know when you run a FireMonkey application, it seems to kind of complain if you don't have one of them down. But it does seem to run okay for a VCL one. I think it might create one just kind of on the fly in the background if it's just a VCL app. Without knowing 100%, I need to check the documentation a bit further. I'd probably recommend just putting one down and setting it to console, so it's not going to be putting any dialogues up or trying to invoke any dialogues, because the whole thing of it is trying to maintain and manage the cursor to inform the user about what's going on without you having to do all the code to say, okay, change the screen cursor, now go run this big long process, now change it back. It kind of just manages that for you, which is kind of cool.
And they put in there saying, you know, if it needs one and you don't have one, you'll get a runtime exception.
Yeah, you'll know right away.
So for a service, though, you might, I don't know where an exception happens when a service.
Event log.
Event log, there you go.
All right, what are the 3 main reasons, only 3, to switch from ADO DBGO components to FireDAC for Microsoft SQL Server environment?
Probably speed, and speed.
Okay, there we go. Perfect.
Yeah, I'd say probably speed is a big one. I've literally had customers on the recent World Tour that we've been chatting with over dinner, and they've been saying how much faster their application is having moved from ADO to FireDAC connecting to MS SQL Server. The other thing is if you ever wish to move to a different database platform, because of the field mapping that's within FireDAC, then you can actually go and change to another database a lot easier, where it may have been a problem in the past, especially if you've got different fields for kind of date time and TSQL date time and stuff like that. You can actually map between those, so FireDAC will take care of that mapping and make it very, very easy to switch.
So someone just tried to connect to a MySQL database and got an error about the libmysql.dll, and wanted to know if those were included with Delphi or they had to install those separately.
I think you may need to install MySQL.
Yeah, they have to be found on a path, the DLL somewhere. So
yeah.
Yeah, the only database I think that you wouldn't need to install a client for would be like
SQLite.
SQLite, yeah, because it's embedded. Anything that's not an embedded database, you need to have the drivers installed for. I think is a pretty good rule of thumb. It seems connection.
We make that pretty easy within the IDE as well with the deployment options. So, for example, with InterBase, you just go in there and you just turn on the options for InterBase, and it'll then bundle everything into your application. So it's just a tick box on the project. So that there are a few that it's quite easy to deploy them out, even if they are there.
Yeah, for mobile development. It seems connection pooling is built in. How do I request a new connection from within a thread from the pool? And then they have a link to the
I posted a reply to one of the other questions. There's some very, very good stuff on docs.embarcadero.com. If you go there and have a look at the Rad Studio FireDAC documentation, there's some stuff in there that tells you about how to do the multi-threading stuff. I think you need to put the FD manager down. I'm trying to remember the component off the top of my head, but that'll help with the threading side of things.
I'm not sure how using a FireDAC query really saves time over just using a direct SQL statement. There seems to be a lot of overhead in setting up the query.
They're just direct SQL statements that are running through FireDAC as the connection to the database. I'm not quite sure what he's really kind of aiming at there. There is the ability within FireDAC to use specific syntax to allow you to have the same query component talk to different databases in different ways. So if you want to take advantage of specific database features within your SQL query, then there is kind of a macro language that you can get into that will allow you to do some really advanced stuff with queries. But yeah, it really depends what you want to do and how simple you want to make it, or if you want to take advantage of some of the features that different databases give you if you're using and connecting to multiple different databases through the same components.
Okay, we're about 10 after here, so let's just do one or two more here. When you loop through a query data set, like you did in your example, and add 10 to the salary, what happens under the hood? Does it send multiple SQL statements in the base?
That's updating the delta, and then when you apply updates, it just sends the delta down to the server and hits it through.
Could login prompt be false by default?
Make a feature request in Code Central.
or inherit from the component, create your own, call your own component. In the constructor of your component, just set login prompt to false and use that ancestor component.
That's the way to do it.
Yeah.
I'm a big fan of that way. I do that a lot. Someone was just...
There's one more just down here about what's the main advantages of InterBase over Firebird. Obviously, with the InterBase on mobile, you've only got one choice. Firebird doesn't have an embedded version that you can run on the mobile platforms. Also on disk, InterBase has all the full encryption, which we were talking about in the previous section, which you don't have in Firebird. The garbage collection stuff that's been done within InterBase to stop the database growing exponentially over time, which often with a Firebird database you need to back it up and restore it quite regularly to stop the disk space growing a lot, which is especially true if you're using blobs in your database. The InterBase guys took care of that ages ago. And the single multi-processing stuff with InterBase, which allows you to use multiple processors on the same machine. I know the Firebird guys have had that in the roadmap for a long time, but they've still not got that delivered. So there's quite a lot of good reasons to use InterBase, and having the free version on mobile, which gives you the upgrade path to offer a more encrypted and data secure version, as we saw in the last session, is a massive good reason.
Thank you so much again, Stephen, for two great back-to-back sessions on InterBase and FireDAC and mobile development, security, all this. Lots of good information here.
I'll triage a few of these questions over the next little bit as well.
Great, thank you. Yeah.
Great.